Hello guys, you're welcome to Chemistry Hangout. I want to believe you're doing fine. I want to say congratulations to all my Chemistry Hangout families, the students, for the chemistry practical. That was wonderful. I will give all glory to God. I want to believe you're fine. If you are just watching this YouTube channel for the very first time, kindly subscribe to this channel and click on the notification bell so that when we upload any video, you are going to be notified. This is Chemistry Hangout, and we are going to have a nice time today. We are going to be taking a twist today. Don't be surprised. Yes, we are going to be taking a twist today, and today we are going to be showing you the Physics 2024 practical. We are going to be doing a pre-practical for the 2024 Physics practical, so that you can have this confidence. You don't need anybody to help you in the exam, and that's why we'll sit down to do a whole lot of research and a whole lot of analysis about the instruction that is given to us. So for question 1, we're going to be talking about question 1 today. We're going to be performing the practical, and we're going to be generating our readings. I want to believe you are ready. So take a seat and listen attentively so that you will not miss today's class. Very important today, as you know, for WAEC students, 2024 WAEC students, the questions for physics are 3. The number 1 is on mechanics, the number 2 is on light, that's optics, and the number 3 is on electricity. So today we're going to be talking about the mechanics. What do WAEC give us? What did they actually give us? Okay, and we are going to be talking about what are we expecting in the exam based on what we have seen, based on the instructions sent to us. What are we expecting them to give you? So let's look at the instruction that is given to us. Those things listed in the instruction. For question 1, we have the retort stand, we have the spring balance, we have the beaker, we have the water, we have masses, we have liquid labeled the liquid will be kerosene as labeled like this, you know. You just label something like this in your exam, labeled L, but it says kerosene, fine. Then other necessary materials. So other necessary materials might be your ruler, might be your calculator, and the rest. But now, with this thing they have given us, what are we expecting? We are expecting them to test you on 3 things, very important, 3 things. Number 1, we are going to be tested on density. Number 2, we are going to be tested on relative density. And number 3, the wonderful principle in physics we call the Archimedes Principle. These are the 3 principles that we are going to be using in this very particular experiment. Let us talk about density. From our physics class, from our rudiment classes in physics, what is density? So that we can understand, because you know, practical is just like an attestation to what we have read in our textbooks. And I tell you, practical is there to give us, you know, that affirmation that the theory we have read in our textbooks are correct. So what is density? So that it will guide us to understanding what to do. Are we making mistakes? If we are not making mistakes, how do we get our readings and the rest? And that's what we want to talk about. So what is density? Very important. When you talk about density, density measures the heaviness or lightness of a material. When you talk about density, you are talking about how heavy or how light a particular material is. However, when you talk about density again, you are talking about how closely packed. Yes, when you talk about density, you are talking about how closely packed the molecules of a material are. So if a material is densely packed, very closely packed, it means that the density is actually going to shoot up. While if the molecules of a material is less dense, it means that the density will actually go down. So very important. When you talk about density, you are talking about either it measures the lightness or heaviness of a particular material, or we are talking about how closely packed, how tightly packed the molecules or the particles of a material is. And if I'm not forgetting, if you remember, we know that our density, very important, density is mass over volume. It's mass per unit volume. Where our mass is measured in kilogram, right? Our volume is measured in meter cube. So definitely the formula for density, the unit for density will be kilogram per meter cube. You know, the reason I'm taking my time to explain this is because for every practical, for WAEC, there is theory of practical. Definitely for this practical, the questions that you are going to be meeting might be related to either density, relative density, Archimedes Principle, because that's what the practical is all about. So understand, that our density is, the unit is kilogram per meter cube, and the formula for density is mass over volume. I want to believe that is very clear. Okay, let's talk about relative density. Relative density. When you hear the word relative in science, it means you are comparing two things. When you talk about relative, when something is relative, it means you are comparing two things. So when we talk about relative density, it means you are comparing the density of one material to the density of another material. And oftentimes the reference density is water. Yes, because the density of water is around 1 gram per centimeter cube, which is also the same as 1,000 kilogram per meter cube. So we often relate other density to density of water. So when you talk about relative density, you are talking about, the density of one material to another material. You are comparing. And the formula for relative density is density of the substance, okay, the density of the substance to the density of water. The reason why we are taking our time to explain this, don't be surprised that in other questions for the practical, you will be seeing them telling you probably to differentiate this. Because what the practical is all about is density and relative density, Archimedes Principle. I don't know if you are getting that. So with this now, what will be the unit for relative density? It will have no unit. The reason is because density is measured in kilogram per meter cube over this density too will be measured in kilogram per meter cube. This will cancel this definitely. Do you see that? So if they ask me to differentiate, probably in the theory of practical, they ask me to differentiate between density and relative density. You should know what to do. Number one, the formula for density is mass over volume, while the formula for relative density is the density of the substance over the density of water. That's one difference. Number two, the difference again is for density, we measure in what? In kilogram per meter cube, while for relative density, it has no unit. I want to believe that is clear. And that is just what this practical is all about. And because there are masses here, can you see there are masses, which means that you are going to be immersing those mass in water and in kerosene. We are going to be, you are going to be looking at immersing those masses in water and in kerosene. And if you understand that from our rudiment physics, you will understand that when you immerse a body partially or fully in water, what happens? It will lose weight. And what is the principle that guides that? It's Archimedes Principle. Archimedes Principle. So very important because, this is what the practical actually revolves around. Very important. So you can see, we have talked about density, we have talked about relative density, and the reason why we talked about density, we have said that mass over volume. We have masses, and definitely we are going to be immersing them into liquids. So very important. That's why we talked about density. Relative density, very important. This is water, this is kerosene. So we can compare the density of the two of them. Do you get that now? That's why I said relative density is the density of the substance, which is kerosene now, over density of water. Can you see that now? So very, very important. The reason why I'm just trying to do this is so that it will guide us to understanding what the practical is all about, because we will not take a predicted question on mechanics, then we will not perform the practical. So very important, Archimedes Principle. Don't forget that we are being told in our basic classes in physics that when you immerse a body in water, what happens? It will experience an upward force, right? Which means when you immerse a body in water, the weight will decrease. It will be lighter. That's the meaning. So Archimedes Principle states that, we can be asked to state it even in the theory of practical exam. It states that when a body is partially or fully immersed in a fluid, that will be liquid or gases, in a fluid, it experience an upward force. Which is equal to the weight of the liquid weight of the fluid, let me use that because I'm using it, displaced by it. Displaced by it. In simple terms, what the rule is just saying is when you immerse a body in water, okay, let's say for example, of course, for some of us that have seen this practical before, we use an overflow can, which means when you immerse a body in water, some water will leave. If you are using an overflow can, some water will be displaced. So the weight of the water displaced is the weight of the object or the body you have immersed. That's the meaning of what Archimedes is saying. So Archimedes Principle states that when a body is partially or fully immersed in a fluid, it experiences an upward force which is equal to the weight of the fluid displaced by it. It's just like we can use this too. It's just like that's what Archimedes is actually saying. Let's say for example the liquid is on 400, just an example, that the liquid here is 400 and I immersed, let me use water so that it will be clearer. You know this water now is 500, so let's take for example it is 400 ml and I immerse a body there. You know when I immerse a body inside, what happens? The liquid will pop up. Is that not? The liquid will pop up. So let's assume that the liquid popped out to 500 ml. You see that now? So which means that 500 ml minus 400 ml will give me the volume of what I have immersed. So that's why sometimes in physics we use this to determine the volume of an irregular body. When the body is irregular, when I dip it in this water, what happens? It will pop up. So when it pop up, I'll just do the initial volume before minus the final volume, then I'll get that. And that's what Archimedes is just saying. So that's what the practical is actually all about. It's all about density, it's all about relative density, it's all about Archimedes. That's just what the first practical is saying. So stay tuned as we give you the predicted question for the physics mechanism for number 1. We are going to give you a predicted question, we perform the practical, and we get our review. Stay tuned, we'll be right back.
Hello, good day from wherever you are listening to me. This is Titi Lopo from Osun State. If you are a chemistry teacher and you are preparing your students for the coming SSC exams, when I mean SSC exams, I mean both WAEC and NECO, then this video from Chemistry Hangout is the perfect thing you need to successfully conduct practicals for your students. In this video, you learn everything you need to know about practicals, even if you've never conducted chemistry practicals before. For me personally, this video has been an eye-opener because I've really learned a lot of things. You learn how to prepare reagents from scratch, even if you've not done it before. You learn how to predict chemistry practical WAEC for WAEC and NECO accurately. Even if it's not 100%, then it will be 95 to 100%. You learn how to predict it accurately and every other thing you need to know about chemistry practicals, even if you are a novice. So if I were you, I would just jump on this because for me personally, I can't wait to take my students down the aisle of making their smooth A's, because this video has given me confidence. And another sweet thing about getting this video is the fact that you'll be able to ask Chemistry Hangout as many questions as possible on areas that are not clear to you. So trust me, you are not alone. You are not alone in this.
Good day everyone, I am Omotosho Abibola Messi, proudly a 100 level biochem student from Kwara State College of Education, Oro. Saying the biggest thank you will not be enough to express my fondness for Chemistry Hangout. It has really helped me for a whole lot of revelation in certain topics in chemistry. It helped me in understanding basic, intermediate and advanced topics in chemistry all through my WAEC and JAM. So do you have problem understanding certain topics in chemistry? Do you want all phobias for chemistry to fly away? Then the best channel is Chemistry Hangout. So subscribe to this channel and you say bye-bye to chemophobia.
Well, welcome back. This is Chemistry Hangout. I want to believe you understood the analysis of the mechanism practical we are about to do. I've talked about density, I've talked about relative density, I've talked about Archimedes Principle, and we're going to be combining all that now to carry out this practical, very wonderful practical. So stay with me. If you are yet to subscribe to this channel, click on the subscribe button and turn on the notification bell so that you can be updated when I release any video. So you're welcome. So let's go to the predicted question for the mechanism. Now, remember that this is a predicted question. When I tell you, this is how the practical will go. Of course, there might be change in some values or there might be change in some letters. but this is how the practical is going to be. So let's see. And that's one wonderful thing about physics, very wonderful, because I'm going to give you the setup diagram. The diagram is going to be there that will tell you what you are about to do. So, and if you look at the diagram, they have even labeled it for us. Wonderful and fantastic. So we have a retort stand, and we have a beaker. In this beaker, we have water, and in water we have the masses immersed in it. We have two of it like that. Same diagram, but the only difference here is that here is the liquid L, here is the water. Do you get that now? Because if you remember the instruction they gave us, they said one liquid labeled L and water. So the only difference between these is that you have water here and you have the liquid labeled L, which is kerosene here. So if you don't have two retort stand in your school, that's not a problem. You can actually use one, which is what I will be using. First conduct what they ask you to do in water, then after that you conduct what they ask you to do in what? In kerosene, and that is very easy. So now let's see. They said you are provided with a retort stand, a spring balance, a retort stand, definitely, a spring balance. You can see my spring balance is already there. Masses, these are my masses, and a beaker containing water, another beaker containing labeled L, and other necessary material. So this is my water, you can see, labeled water, and this is my liquid L. You can see that now. Okay, very important. So what did they ask us to do? They said suspend the mass N 20 gram. It can be 50, can be 100, can be 150, but now we are using suspend the mass N 20 gram on the spring balance and measure the weight in air. I hope you are getting that now. So we want to measure the weight of the mass 20 gram in air. So that's where we are going to start from. So let us use this book first so that we can get all our values. I'll just be writing those our values here. Then we can now transfer to the board. Okay, so let's leave it there. And let's get started now. So this is my mass of 20. If you look at it, it's 20 here already, written 20. Okay, so and here, very important, you have your spring balance in gram. You can see this. This one is in gram. If you turn it, this will be in what? In Newton. So, but what did they ask us to do? They said, measure the weight in air, WA, in Newton. So we are using the Newton calibration of our spring balance. Okay, so let us go. So this is my, let me do this here, so that when I want to put the beaker, it will be easier. Fine. Okay, so that's perfect. So let's see in air now. You can see that in air. So you know my calibration is 0, then is 0.5. If you look at the calibration, that's why you have to study the calibration of your spring balance first before you take measurements. Very important. So if you look at this is 0, this is 0.5. So I want to know the value for each line. So I can just say 0.5 since I have 10 lines to 0.5. So I can say 0.5 divided by 10, and that will be 0.05. You get that now? It's 0.05. So each line of my spring balance is 0.05. So let's see. So this is on the fourth line now. Come on, let the camera come very close. You can see this is on the fourth line now. So the fourth line, meaning, and we have said that one of those lines is 0.5. Is that not? So times 4 now, you give me is 0.2. I want to believe that is clear. So I can record my weight from mass 20 gram. Okay, from mass 20 gram, my weight in air is 0.20 Newton. How do I know that is correct? How do you know that is correct? Look at something. Of course, and that's the reason why I said the theory cannot contradict the practical. If our measuring instruments are working fine, then we should not have it. Why? How do we infer it is correct? Definitely, because our weight is mg. Is that not? So, and our mass, for this formula to work, our mass has to be what? In kilogram. And if you look at this one, I have 20 gram. So I'm converting to kilogram. We know that 1,000 gram is 1 kilogram. Is that not? So I'm going to divide, since I'm not converting 20 gram to kilogram, I'll divide by 1,000. So we have 0.2 divide 1,000, sorry, 20, because that's the mass now. 20 divide 1,000. That's giving me is 0.02. which means my weight here, the mass now, you know, I've converted the 20 gram now to kilogram, so it will be 0.02, and times our g, that's acceleration due to gravity, which is actually constant, so we're taking 10, so 0.02 times 10 is still giving us what? 0.2. Can you see that now? Which is the same with the readings on our spring balance. So, which means that you have to be very intelligent and smart when it comes to physics. You have to be very, very intelligent and very, very smart. So, which means that, look at this, look at the practical, 20 gram, we are going to do that for 40 gram, we are going to do that for 60 gram, we are going to do that for 80 gram, and we are going to do that for 100 gram. Can you see that? We do that for 40 gram, for 60 gram, for 80 gram, and for 100 gram. So our weight in air is 0.20. I want to believe that is clear now. So they now said, what's the next thing? They said, immerse the suspended mass completely in water and measure the weight in water. Please note all this. WW. It might be any letter on that day, but note all these things. So don't forget, they said measure the weight in air, WA. Can you see? So my WA for 20 gram, my WA is 0.20 Newton. Let me take to 3 decimal places. And the reason why I'm taking to 3 decimal places is because I have conducted this practical and I saw that the values are very close because the density of water is closer to kerosene. Kerosene is around 0.83 if I'm not mistaken, and water is around 1. You can see there is proximity. So if you are not very careful, it will seem as if the spring balance is reading the same thing in water and in kerosene, which is not true. And how do we know that our values are correct? I will show you something as we proceed. So let me use 0.0200 Newton now for 3 decimal. So our W, that's in air. In water now, that's WW. Don't forget for 20 gram, right? So, and this is our water now. So let's go. Let me adjust this up. So, and very important, you know, there is difference between partial immersion and full immersion. So this very particular person said, water, I measure the weight in this. So we are suspending, we are immersing fully. Yes, we are immersing fully. So I'm immersing fully in water. Let's go. That's the total immersion. Now, very important, one of the precautions is that the mass must not touch the side of the beaker or the bottom of the beaker. I hope that is clear. So it will not touch the side nor the bottom. So very important, don't let it touch the side. So in water now. Okay, if you look at my spring balance now, it has shoot up. You can see it has shoot up. So let me, this is 1, 2, okay, 0. That's in between these. So I have 0.1. Let me use my calculator. So that's 0.005, 2.5. Okay, so that would be 0.170. Very important now. Is 0.170 Newton. That's the weight in water now. Okay, so but what I will advise is this. Let's finish the water first, then we take the kerosene so that we don't just begin to exchange every time. So let's do this one. So we have gotten the weight in air for 20 gram, then we have gotten the weight in water for 20 gram. I want to believe this is very, very clear. Okay, so let's move on. So we remove this now. Let's take it off. So let me clean the water there. Okay. Then we increase the mass now. We increase the mass. Very important. We increase the mass. We increase the mass. Let's increase to 40 gram now. You know, we have done for 20. Now look at this. That's why I said there is no time for you as student. There is a particular theory that guides this practical. Now look at something. Look at something. So if for for 20 gram, if it is 0.2, by using our weight equal to mg, which means the spring balance for 40, that means to be 0.04 times 10. Is that not? Because it means that I've converted the 40 gram to kilogram, and it should now be 0.04. This is times 10. So which means that the weight in air will just be like 0.2, 0.4. For if your spring balance is accurate, this is what you should be reading: 0.6, 0.8, and 1.0. Because our weight is what is empty. You don't have time because you are doing graphing, you are solving some theory of questions, you are solving some theory of practical questions again, and you are plotting graph again. You have to be intelligent, you have to be smart. So, and that's the reason why, if you look at it now, I'll just do this, then we use the formula to get that. Look at this. Can you see that now? Do you see that? Do you see now? So that's what is 0.04 on my spring balance. So, which means that for mass that is 40 gram, the weight in air is 0.40. I want to believe you understood how I got that. So for 60 gram, the weight in air is going to be what? 0.60, right? For 80 gram, the weight in air is going to be 0.80, right? While for mass for 100 gram, the weight in what? In air will be 1.00. I'm still going to arrange that on the board. So that you don't waste your time. If we put it like that, if I increase it, it's going to give me 0.6. Can you see? Did you see that? After is 0. What? Is 0.5. This is 0.5. You can see. So that's just the rule. That's the rule. So very, very important. So I'll do 40 in water. Since I've gotten all my weight in air, I'll do 40 in water, 60 in water, 80 in water, and 100. Then I'll exchange. Very simple, practical. So we are doing 40 now in water now. 40 in water. Don't forget 40 in water. 40 in water. Don't forget the rule. Don't allow you to touch the side of the beaker or the bottom of the beaker. So let's do our full immersion. Can you see that now? Should not touch. Okay, good, it's not touching. So let's see. Let me get my. That's for. This is 0.350. You can see that now. 0.350. So our 40 gram in what? In water now is 0.350. I want to believe you are still following. So this practical is very, very simple. The calibration of my own spring balance might actually be different from the calibration of your spring balance, but just understand the calibration first of your spring balance, and we should be getting very closer. If we are using the same, if we are actually using the same mass, then our values should be very, very close. I want to believe that is clear. So that's for 40. Let's move to 60. Let me remove this. Sorry. Let me clean this a bit. Since it's what I use, so now. So this is 60 now. We are adding 20 now. So in air, we have already gotten that. So 60 in water again. Let's go. So we go again. Don't forget, it should not touch, and it should be a what? A full immersion. Don't forget. So we are still going down. So let's go now. Okay, this is a bit more than 0.5. It's a bit more than that. So let's have. Don't forget, we said our value is 0.05, and this is a bit more than 0.5. Do you get that? So plus our value now. So what do we have? We are going to have for weight, for 60 gram weight in water, it is 0.540. You know, because it's not, it's actually a bit above the 0.5. So that is that. For 80 now, let's have for 80. So let me just do like this. Since it's water, we don't have issue. So this is another 20. I want to believe this is clear. Another 20, making 80. Let's add up. You know that we've already gotten our weight in air already using our formula. So let's immerse. Full immersion. Don't forget the rule, should not touch the bottom of the beaker or the side of the beaker. I want to believe that is clear. So let's go. You can see, please help us with the camera. You can see it's not more than a 0.5. Look at it on the third. So this is 0.05, 0.05, a bit not more. If you look at it now, 1, 2, like on the third line, if you are looking at that. So, and we know each of our values is 0.05. Do you understand that now? So we should be having weight in water now. That's 0.725. Say 725. So let me, since I'm using 0.540, I'm taking to 3 decimal place. So 725 for 80, right? For 100 now, which is the last one now for water. So for 100, let's go up again. Very simple. Just understand the calibration of your own spring balance. Then we are going to get the same. So here, 100, right? Full immersion now. Full immersion. Let's go. Full immersion, let's go. Oh, wonderful. Now look at that. Not up to, that's 5, 6, 7, that's 9. So we have our weight in water is 0.900. Do you see that? So we are getting our weight in water for 20 gram, we got 0.170. For 40 gram, we got 0.350. For 60 gram, we got 0.540. For 80 gram, we got 0.725. And for 100 gram, we got 0.900. I want to believe we are still together. So that is that for water. Then we can now do for what? For the liquid L, which is kerosene now. So we take this off. Take this off. Let's with the water that we have here. And don't forget, we are not even using everything now. We are taking only 20. So we do for what? For kerosene again for 20, for 40, for 60, for 80, and for 100. And that's, we are done. Then we can now do our tabulations and you see how it's going to look like. I will still explain something here, but let's finish the practical. So you even know if your practical is correct or it is wrong. And the reason is because, you know, water is denser than kerosene. So, and a body immersed in kerosene will weigh more than that of water. Yes, we weigh more because kerosene is less dense. I don't know if you get that. Kerosene is less dense than water, which means kerosene should weigh more. A body immersed in kerosene should weigh more than that of water, which means if I get values above the one I got for water for kerosene, it means that I am doing the wrong thing, because the theory must always agree with the practical. So, and don't forget, look at it when we are doing the practical, we are using the same volume. Very important now, the same volume. I think, is it specified in the question? Let's see. In the liquid, okay, you can see that now. Immerse the suspended mass completely in the liquid L of same volume. So if you are using 200 of this, you have to use 200 of this. If you are using 200 centimeter cube of water, you have to use 200 centimeter cube of kerosene. So very important. So I'm using 500, 500. And the reason I choose to use 500 is so that it will be fully immersed in the liquid. Okay, so I would advise you use 500 too. So let's go now for kerosene labeled L now. Can you see that? Let's go for kerosene now. Don't forget the rule. It must not touch the side of the beaker or the bottom of the beaker. I want to believe you are clear. So let's go. Okay. Okay. Don't forget the rule. It must not touch the side of the beaker or the bottom of the beaker. I hope it's not touching the side. Let me immerse gently again so that we full immersion. Okay, good one. So let's see. Wow. 0.175. So don't forget, this one now is in kerosene now. Okay, in kerosene. So we have that. So we have that weight in what? In the liquid now. For that's 0.175. I want to believe that is clear. 0.175. Very, very important. So let's go on with 40. Let's immerse 40. So this 40 now. Sorry. I think there's a splash there. Okay. Let's go. Very simple practical. Very simple practical. Okay, it's like it's touching. Not touch. Okay, that's why I said you have to be very careful of your spring balance reading. If you are not very vast with the reading, you think they are the same, but they are not actually the same. They are not actually the same. 0.123. Okay, 360 is 0.360. For 40 now, 0.360. Very, very important now. Okay, so let's move. So that's for 40. So we are left with 60. Let me take it up gently so that the kerosene will not. This 60 now. So let's immerse. Hope it's not touching. Okay, it's not touching. Good. So let's see this. 0.55. I think I'm seeing 55. 1, 2, 0.550. Weight in the liquid is 0.550. So if you are not very careful, you are not going to get those readings. So please understand the calibration of your spring balance. Very, very important. Very, very important. So let's move to 80 now. Let's move to 80, then 100, and we are hoping for the practical. So we just do our calculations. Okay, so this for 80 now. Let's go down. Okay. Point 6, 7, 4. 0.74. Weight in liquid 0.740. 0.740. Please, that's what I've told you. Very, very important. Understand the readings of your spring balance. The readings of my spring balance, the calibration might not be the same with your own. However, if you understand the reading of your spring balance, you will still be getting a closer value. That's if you are using the same, if you are using the same mass with me. You know, the question can be 50, 100, 150, 200. Definitely, we are not going to understand the readings of your spring balance. Very important, because that's the major thing in this practical. Your readings on the spring balance is the major thing here. So the accuracy is very important. So understand it. And very important, read the question, please. Read the question. You know, for my predicted question, I am using 20 gram, 40 gram, 60 gram, 80 gram, 100 gram. The question on that day can be, you know, you using 50, 100, 150, 200. However, if you are using the same 20 gram, then your value should be closer. If the question is coming like it is 20 gram, because in the instruction given to us, they didn't specify the mass. They didn't specify the mass. It just said masses. So I am using 20 gram, and that is that. So let's go for 100 now. Then we are done with this. Then we do our tabulations, and that will be all for today. So in our next video, I'm going to do another video where I'm going to talk about the graph. So we are actually going to stop here, which is tabulate your readings. Okay. So I'm going to do another video where I'll talk about the graph, talk about how to determine the slope, and some of the WAEC guidelines for drawing graphs. So that's that. So let's go to 100 now. Let's go to 100, which is the last one now. Let's fully immerse. Don't forget the rule. It must not touch the side of the beaker or the bottom of the beaker. I hope it's not touching. Okay, it's not. It's not touching. Yeah, it's not. So let's see this. 1791.2. So I have 0.56782. So the weight in the liquid is 0.92. Let me say 0 now. You know, 0.92. It's 0.92. I just want to put it in 3 decimal place so that, you know, it will not be that, it will not choke. So that I'll be able to plot my graph nicely. So that is that for that. So we have gotten our weight in air, weight in water, and weight in liquid. Now, very important now, let us now go to our table. They said tabulate your readings. Please, very important here now. So all the stress we have gone through, we want to tabulate it now. Do you understand? Our result now, we want to tabulate. So we say this is our serial number. Okay? Our serial number. Then our mass, very important. Our mass, don't forget that one is in what? Is in gram. Very important. Then what is another thing? The weight in air, WA. Can you see that? WA. Weight in air. So I can put weight in air. Don't forget the unit is in Newton, right? So that's our weight in air. Then after that, our weight in air, then immerse the suspended mass completely in water and measure the weight in water, WW in Newton. So the next thing now is the weight in water. That's WW. So that's W, weight in water. Don't forget the units, very important, in Newton also. Then what's the next thing? Evaluate U. WA minus WW. That's that. WA minus WW. So we move here to say our A, okay, our U, U here, let's say U equals what? WA minus WW. That will also be in Newton. I want to believe this is clear. Then we go to this place. The only thing we are left here with V, right? Because we already know the weight in the liquid. Have we done that? WL, okay, it's not there, so we have to do our WL. Because they say I measured the weight in the liquid WL. So the weight in the liquid now, which is kerosene now, the weight in the liquid, the weight in the liquid, that's also in what? In Newton. I want to believe this is clear. Then we now have what? Our V now, which is the weight in air minus weight in the liquid. So our V, which is equal to weight in air minus weight in the liquid in what? Newton. You can see the units are well stated. This is my serial number. This is mass in gram. The weight in air in Newton. The weight in water in Newton. The U, which is weight in air minus weight in water in Newton. The weight in the liquid, that's the kerosene in Newton. Then my V, the weight in air minus weight in the liquid, which is kerosene. So, and don't forget, this one will be 1, 2, 3, 4, and what? And 5. So the gram we started with us 20.0. I'll have to put it in one decimal place. So 40.0, right? 60.0, 80.0, 100.0. I want to believe this is clear. So the weight in air in Newton, if you remember, we just used our formula because our spring balance is saying the same. So we have the 0.2 here, we have the 0.4, we have the 0.6, we have the 0.8, and we have 1.0. I want to believe this is clear now. So our weight in water now. So let me go. You know, I told you I'm doing this in 3 decimal now because of the closeness of those values. So I can just do 0.200, okay, 0.400, 0.600, 0.800, and 1.000. You get that now? So my weight in water now. So here I have 0.17. So let me say 0.170. At least the 2 decimal place. That's if you are taking readings from a particular instrument, at least it has to be to 2 decimal. At least. If it is you are taking instrument, you are taking measurement for a particular instrument, maybe voltmeter, maybe all those ammeter, you understand it. At least it has to be to 2. For me, it has to be to 2 decimal place. But if it is the value that you are giving, you know, like this 20 now, we are giving in the question, I take it to 1 decimal. But if it is a value I got from an instrument, I take it to at least 2. Why if it is my calculator value, you know, sometimes on the calculator you just have 0.200, you know, 0.2317 like that. You take that to 3. So that's the reason why I decided to take this to 3. Now at least 2, so we take to 3. So weight in the liquid now. Weight in the liquid, we did that 0.175, right? So for this one, in water, we have 0.350. Then, okay, thank you. This one we have 0.360. Then we have 0.540. We have 0.550 here. Then we have 0.725 here. We have 0.740 here. Then the last one, we have 0.900 here. And we have 0.920. I want to believe that's clear. So that's just what we need. The rest one is just to subtract. So our UV, weight in air minus weight in water. So this minus this, that's what we are doing. So 0.200 minus 0.170. And that's giving us 0.030. So 0.4 minus 0.35. That's giving us 0.050. I want to believe this is clear. 0.6 minus 0.54. That's giving us 0.060. Okay? So 0.8 minus 0.725. That's giving us 0.075. And we have 1 minus this, definitely. We have 1.0 minus 0.9, sure. So this is 0.100. I want to believe this is clear. So some people will do, you can do that. Some people will do 0.17, 0.35, 0.54, 0.73, 0.90, then yeah, no, but I choose to go by 3 decimal so that it will be easier for me. So V. So we have weight in air minus weight in the liquid now. You can see. So this will be minus this. So we have 0.200 minus 0.175. So this is 0.075. 0.025. Then this one we have 0.400 minus 0.360. That's 0.040, because I'm taking to 3 decimal. 0.6 minus 0.55. That's 0.050. Then I have 0.8 minus 0.740. Okay, that's giving me 0.060. Then the last one minus 0.920, and that's giving me 0.8. Can you see that now? So these are the readings generated. These are the beautiful readings we had doing this very simple practical. Just the only thing here is understand the readings of your spring. The spring balance reading is the main thing here. If you get it, then you are done with the practical. Because what you are just doing is, I already told you how to get all this your weight in air. You can use your W equals to mg. So the only thing here is you get the weight in water and the weight in the liquid. All other things are just subtraction. Okay, so, and if you are very lucky that on that day the mass they use is 20 grams. In fact, if you understand this practical, is, you know, it's just an express A1 for you. Because if they use 20 as the gram on that day, definitely the readings will be very close. The readings will be very close. So you pray that they use 20. They use 20, then our readings is perfectly correct. Okay, so from there, what do we do? Tabulate your readings. We have done that. These are our readings. And the next one is plot a graph of U on the vertical axis and V on the horizontal axis. Sometimes they use the ordinate and the abscissa. The ordinate is the Y, the abscissa is the X. But here they are even straightforward. Said on the vertical, so which means I'm drawing a graph like this. The vertical axis will be U. They plot a graph of U on the vertical, so the vertical will be U and the horizontal will be V. So we are going to do that in another video. We don't want this video to be very long or to be too long. The aim here is to do the practical. So in our other video, we're going to talk about how to plot the graph using WAEC marking guide. We show some of the things that WAEC needs us to do when it comes to graphing. Then we talk about the slope in another video. We talk about how we can evaluate this. We talk about the precautions. In fact, I've taken all this in the theory of the practical, but we're still going to talk about that. This is Chemistry Hangout, and if you have not subscribed to this channel, you are not doing yourself any good. Why have you come closer, come? Why have you not subscribed? We gave you predictions in chemistry. We have been doing that for years. God has been helping us just to help people to pass, and you have not still subscribed to this channel. You are not doing well, though. You are not doing well. Subscribe to this channel, and you can, because I said we are still going to dropping some updates on Facebook. Very important. Still same name, Chemistry Hangout on Facebook. Share this video to your friends. Students are very funny. You want to keep this premium information to yourself.
Do not mind.